I haven't even started my project Euler series, and just like I was expecting, I got calls that, yo, you didn't optimize that function right. You didn't have to iterate through the entire list of numbers just to get the right answer on this one. And yes, you are right. That is when I thought about a much more interesting way of doing this. And now I am introducing a completely new challenge. See, as I keep posting videos, there is always two kinds of solutions. One is the brute force version, which is for this question iterating from 3 to the max number and running if condition, and whenever I is a multiple of 3 or I is a multiple of 5, it will just add to the set. Now I also failed to realize that we didn't really need the set data structure for this, because we are iterating only once throughout the range, so we didn't really need the set data structure to play a role in this. But let me tell you, we will need set if we are going to go for the optimized version. Let's see the optimized version. We are iterating with a step of 3 and adding all the numbers to the multiple set. Once again, we are iterating with the numbers but with a step of 5, which means throughout all of this we are not iterating through a single number which we do not need to add to our set. And since this is a set, it ensures that if we add a multiple of 3 as well as a multiple of 5, for example 15, there's only one 15 in the set. This is a much more optimized solution. First, let's make sure that this function works, for which I have written a test over here in test slash multiples of 3 and 5 underscore test dot dot. Now you'll see group 1, which is P1 brute force, and group 2, which is P1 optimized, P1 obviously standing for problem 1. And as you can see, I've imported two packages, one as BF, which is brute force, other as optimized. Now we are ensuring that both the solutions are correct, which means they are giving the right output. If we pass 10 to the function, we are getting return 23. If we pass 1000 to the function, we are getting return 233,168. Same needs to be true for the optimized function, which is why we're using the same test cases. If I run all these tests, we'll see that in the debug console, all of these tests are passed, which means our optimized version of the same function is also returning the right solutions, which means it is correct, which is the first step of optimization. The function still needs to be correct. Now the second step to understand is how much did we gain by this optimization, for which if you go to main.dart, we are running a benchmark function to which we pass the function, and then we pass the parameter, and then we pass the number of times we want this function to be called. This will print the amount of time it will take, and finally we will calculate a percentage improvement and print it to the console. It's pretty simple. Running this main function, I get a percentage improvement of 36.72, and if I'm running this main function again, 33.88, and run this main function again, it's 37.52. So it's a range between 30 to 40%, and it depends upon many factors, including which thread is available and not. So let's say it's between 33 to 40%. Now what I'm willing to do is, if you clone this repository, link will be in the description, you go to multiples of 3 and 5 optimized dot dart, which is under the P1 folder in the SRC folder, and you write your own implementation over here. After you have written your own implementation of this, you need to go to tests and run the tests to ensure that your solution is correct, and then you can go to main.dart and run this, and you'll see the percentage improvement. Now, my percentage improvement is somewhere between 32 and 40. If you come up with a solution which has a percentage improvement in a much higher range, like 50 to 60% or 70 to 80%, I will feature your solution as the super optimized solution. So, this is a challenge that I hope we all will love. And like this begins with, obviously, the brute force version, which means we are solving a maths problem with computers. Then this is the optimized problem, wherein like we use maths to make the computer's task easier, and the percentage optimization that we get is kind of a score. And let's see who gets the best percentage improvement out of this. If your percentage improvement is way greater than mine, I'll check this on the same PC, the same processor, with the same environment and everything, and we will feature your solution in our channel in a separate video as community submission. That's it for today's video. If you're up to the challenge, feel free to get in touch. Subscribe, like the video, because we're going to have a lot of fun with this. And stay tuned for the brute force version of the second Euler problem coming out tomorrow.